Okay, why don't we start with your name and your current position?
Perfect. Yeah. My name's Justin Isaacs. I'm a director in the auto manufacturing team here in Detroit. I'm also seconded 100% to one of our group companies, SC Automotive Engineering USA. I was one of the original founders of that business line in the US back in, we started that back in 2020, officially carved it out in 2022. So at the group company, I'm vice president. I have quite a few titles actually at the company. Vice president, principal, and then I'm on the board of directors as secretary and treasurer.
Okay, why don't we start at the beginning? Where did you grow up?
Yeah, I grew up, I'm a New Yorker. I lost my accent quite a bit over the years, but I grew up in Long Island till I was about 17, and then I moved to Michigan, not full time at that point, but I went to University of Michigan for a mechanical engineering degree. Best thing that ever happened, met my wife at school, and she's from this area, and so we stayed out here. All of my job offers at the time were in automotive, and Metro Detroit is one of the largest hubs of automotive and mobility for that matter. So my career kept me in Michigan, which I'm very thankful about.
Now, your initial interest in engineering came from where?
Man, I was a Legos kid. Really, I loved Legos. I loved rocketry. Dad wasn't a huge car guy, but I was always fascinated by it. He had a Mustang when I was growing up, so just always really fascinated with mechanical and electrical systems. Definitely somewhat of a gearhead myself. Definitely once I started living in this area with the huge crowd of automotive enthusiasts in this area, it's hard not to be.
So, what were some of the cars that got you excited when you were young and when you were coming up?
I think I had every Lamborghini poster that ever existed.
Wow. Wow.
Yeah, I was
Wow.
a big Lamborghini guy. All the exotic Italian cars were always really impressive to me. The Ferraris, the Lambos, the Porsches, all those were always super fun to pretend and
Mhm.
hopefully get to drive. Still have not gotten any seat time in a Lambo, so that's on my bucket list.
Oh, that's great. Okay. Well, I hope that happens. So let's take it from when you graduated from college. What was the first job that you had out of school?
My first job was with Chrysler Group. Now it's more well known as Stellantis. It's part of the Peugeot family now, but at the time it was Chrysler Group. So it was right after the bailout happened. I joined them in 2011, very shortly after they were acquired by Fiat or merged with Fiat Group. So it then became Fiat Chrysler Automobiles or Automotive CA. So right out of school, I joined a rotational program at Chrysler. So over the course of 2 years, I moved around to six different areas in vehicle integration, powertrain, chassis. I spent some time in a manufacturing facility. We had to do one non-engineering elective or selection. So I did sales and marketing, which was super fascinating because it was really, other side of the house for me at the time. Little would I know that that is some of the best experiences that I've had. And then I also spent some time in their innovation advanced feature development team. And while I was doing that program, I went and got my master's in mechanical engineering.
Okay. So what is the advancement when you go from a bachelor's to a master's when it comes to automotive engineering? What are sort of what's the advanced knowledge base that you gain from something like that?
You certainly get into a lot more of the technical details. I went really far into vehicle dynamics. I went really far into heat transfer. So, like convective and conductive heat transfer, really like internal combustion engine focused. I had a whole powertrains class. One of the classes that I really liked was sustainable energy systems. So, kind of outside of the mobility world, more like hydropower, solar power, wind power. And then one class that I didn't know how much it would really impact my career was project management. We all are project managers in title or not. And so it really It gave me a great foundation for some of the activities that I've done throughout my career and absolutely what I'm doing right now.
Okay, great. So out of the first job up until you got to Sumitomo, anything memorable within that period of time, or was it kind of a just a hop, skip, and a jump to get there?
There hasn't been so many jumps company-wise. It was just more with like for example, within Chrysler, one of my rotations was in SRT chassis. So SRT stands for Street and Race Technology. So those are the really, halo vehicles, the souped up Hellcat Challengers and Vipers, SRT Grand Cherokees, the really high horsepower, get your heart thumping kind of vehicles. And I really fell in love with brake systems because I was working on Viper brakes at the time. And so for the next 2 years, once I got out of the program, I went into the brake team in the chassis department and I was doing brake actuation for 2 years. About a year into that, I was as a second role, I was selected to be a system lead for all of the components in the interior of the vehicle in the center console. So I was responsible for all the sheet metal, all the interior components, the park brake, the shifters, all the HVAC, the air conditioning that goes through there. And one of the really interesting things, it was for the Jeep Wrangler. One of the really interesting things was it was the first year that they went away from a direct shift transmission. So there was cables that had to be fed through the floor as the body moves and meets the chassis because it's a body on frame vehicle. You had to figure out a way to present the cables through the floor. Otherwise, you couldn't fish your hand through there and pull the cables out after. So I was involved in redefining the decking process. That's what it's called when those two components meet. Redefining the decking process. So I got to see some pretty advanced manufacturing engineering, which is, something that I still recall to this day as a great foundation for some of the engineering activities that we're working on. So after that, I spent 5 years at Brembo North America, which is a premier brake company. I was
Oh, okay.
working on full corners, so calipers, rotors, we didn't own the knuckle and the hub and bearing, but we were responsible for making sure the system as a whole functioned as it should. I worked on, I think, 7 concept to SOP programs while I was there, eventually becoming an engineering supervisor there. And I was reached out to by a recruiter who mentioned Sumitomo Corporation of America's. I didn't know who SCOA was at the time. And, I watched the introduction YouTube video that I was sent, and SC or SCOA has their hand in nearly every single industry. I knew automotive manufacturing was the department. It seemed like a wide open world as I was coming into the company, and meeting the team here in Detroit was really fabulous. I really have enjoyed my time here so far. It's been almost 4.5 years now.
Okay. To kind of connect the past and the present, what is it about brake systems and that part of the car that keeps your interest or kept your interest at the time?
First off, it's a safety system, so you can't mess it up. If you mess it up, then people can die. And so we really take everything that we do in that space very seriously. To me, it's where engineering's at its finest because it's all about trade-offs. It's about making the right decisions for the specific applications of, you can oversize your system and spend $1,000 per vehicle on your brake system, but for an entry-level vehicle, it's completely unnecessary. So it's about sizing the system correctly for heat management, structural integrity, cost, of course, development timing. There are a lot of changes that are happening in the industry with regenerative braking or electromechanical systems like electronic parking brakes, where you start to get into these, what if my brakes fail? Can I use my EPB, my electronic park brake, to stop my vehicle? And then you run through all these kind of failure mode scenarios to make it as safe as possible for the end user. So I'd say what brake systems really are attractive for me because the application dictates the solution. It's not a one size fits all. So it definitely requires a lot of, systems engineering approach to make sure you release the right component for the right application at the right time.
It's been my experience when talking to engineers that the engineering world and the business world have to sort of meet halfway. But the problem with the engineers is that the laws of physics and engineering do not meet halfway. That's why they're called laws.
Mhm.
So when you have had situations where there's obviously limited budget or limited time, you have to make sure that the system that you're working on, as you said, is damn near perfect. How are you able to sort of maneuver within that? Or have the companies that you've worked for always understood that?
I think there's areas, I mean, I don't want to use the word cut corners because absolutely never you do cut corners, but I
Sure.
think there's times when you can, let's say, reduce sample counts when you're trying to run, test to failure, where you've already confirmed that things are okay. You're just trying to, check every single box where you don't necessarily not do them, but you can kind of do them in parallel to some other activities. That's maybe one of the main things that comes to mind. However, it all comes down to planning, and that's where I mentioned project management earlier, is you have to have the right plan from the beginning and understand if you build your plan working forwards, where does it put you? And if you build your plan working backwards, are you already too late? Or do you have to make some concessions? Or do you have to change the requirements? Most of the time, it's those discussions with the customer on how do we modify the requirements or how can we adjust what this has to do from a performance or feature or functionality standpoint so that we're confident we can put products into production that are we know are safe, we know are reliable, and we know aren't going to yield, massive warranty issues because nobody wants that. There was one customer in particular, I won't name them here. They wanted to go into production with DV level parts. So DV stands for design validation. So these are non-production parts that are used, that basically prototype parts that you're validating the design to say, yeah, this works, and then you're going to revalidate it again after you hard tool and produce production parts. And we had to say no to that. I mean, it's not anything that we would ever want to do is hurt business, but similar to Sumitomo Corporation, your reputation is everything, and you never want to do anything that's going to compromise your reputation.
Yeah, you can't skip a step. That's great to hear. So tell me about the formation thereof of SCAEUS. How did that emerge?
So when I was actually mid MBA, when I was reached out to by the recruiter to come join Sumitomo Corporation of Americas, I was always fascinated with the business world. I didn't want to find myself, 20, 30 years from now as just being so narrowly focused on engineering. I wanted to get a bigger picture of how engineering meets business, kind of to your point earlier. So I was right in the middle of my MBA and I joined, and there was two main assignments that I was working on when I joined. The first was brake related, actually. Sumitomo Corporation has a group company called Kiru who manufactures brake rotors. So I was involved in the post-merger integration of two different brake companies that we had acquired, one in 2004 and one in 2019. Those are SC group companies, but
Okay.
they do have in within the Americas, they have four locations currently, one in Michigan, one in Georgia, one in Kentucky, and then one in Mexico. And so I was involved in helping with, how do we bring these two companies together? I was definitely able to leverage my technical knowledge in brakes to have some really fun discussions with some of the folks at these companies. Some of my good friends are still at these companies.
Hmm.
And then my other assignment was to start the engineering business in the US with my manager at the time. We have an engineering business, multiple engineering businesses actually in Japan, but the US is one of the largest markets globally as it pertains to R&D spend for mobility. And so this is a really huge market for us to be involved in. So starting from, week one, we were starting to put together the business strategy, what type of services we would offer, how we would build the business. We started putting budgets together for that. And again, it kind of allowed me to flex kind of where engineering meets business a little bit because I have a really strong foundation in systems engineering from my time both at Chrysler FCA and Brembo, where I understand what it takes to bring components from concept through production, and being able to leverage that direct firsthand experience and offering that sort of a solution to our customers is something that's really fun for me.
Now, what is SCAEUS doing right now that you're really excited about?
Yeah, right now we're branching out significantly outside of our foundation's in automotive, right? It's in our name, SC Automotive Engineering. However, we're really branching out into some other industries, aerospace, off-highway or construction, agriculture. We've had huge successes in the marine industry as well. Something that was really fun for me, I never really considered myself a software guy, a software engineer, but I was thrust into the deep end on some of our projects where, you know, you have to learn and figure it out as you go. And I found myself as a software project manager for a 2-year time period for one of our major customers. We were working with 25 resources that were working on the software. I was making sure everything was remaining on time and keeping the customer happy. We ended up delivering that project really successfully, and it should be going into production within the next year. So it's really fun to see things that you work on that, are just an idea on a napkin at first. And now all of a sudden they're in vehicles, in boats, in planes, even, or in mining equipment. So that's really fun for us. And we get to leverage the groups within Sumitomo Corporation as well. So we get a lot of cross collaboration between the different units.
That's great. Just to jump back for a moment on this, for those who aren't that well versed in the automotive engineering end of things, what does SCAEUS basically do as their main job?
Absolutely. That's a great point. We are engineering consultants and project managers at the, lowest common denominator of what we do. So we work with OEMs and tier ones in the various mobility industries to help strategize, help generate concepts, and then take those product development plans and put them into action. And that can be through things like software coding or mechanical design and packaging. It could be in validation activities. We've done ideation sessions and road mapping for the next 5-10 years of what a customer's products could look like. And we lead, guide, and support our customers in their transition to the new way that mobility is moving, which is really connected, focused, software-defined vehicle. Everything is connected now. Autonomous functionality is coming into not just automotive, but really every industry. And electrified, right? Electrification is a huge area. There's an acronym, a couple of different acronyms out there. CASE, connected, autonomous, shared, and electrified. Some people call it ACEs, which would be autonomous, connected, electrified, shared. It's just kind of a different order. And so those are some of the main areas that we focus in, but we're able to operate really broadly because we leverage our partners and a lot of their subject matter expertise. And we're really focused on making sure that everything is executed in the right way from a project management position.
So when I see you in a testing facility, where generally are those?
Oh, they're globally. We've got some facilities that we leverage in Japan. We've got a ton that we leverage in the US, a lot of them in Michigan because our partners have those facilities locally here, but they're spread out globally.
Okay. Now, sometimes when you're a little bit older, like I am, you run into that sort of old school idea of, wasn't this easier in the 70s and 80s when we didn't have to worry about all these computers and it's just a car and a key? What do you say, having had your time as a gearhead, but when you want to bring people around on this idea that software actually really helps everything? What are some examples that you give for that?
Yeah, there's definitely a school of people who want to be able to do everything themselves, don't want to rely on scan tools, don't want to rely on having to bring their vehicle in. Right to repair, basically, is a big area. I think software, when done correctly, has some huge benefits. And you can see it with Tesla right now. they might have a recall, right? They, 300,000 vehicles need to be recalled. But what that really means is that as it sits in your garage overnight, they're going to send a signal to your vehicle. It's going to update the software. And in the morning, it's going to just have a new version of that software. And without OTA, over the air connectivity capabilities, and the right cybersecurity in place, and the right testing and validation activities that went into making that, you'd be stuck at a dealership. You'd be scheduling your, 3 weeks out, and now you've got to take 3 hours away from work to go sit in a dealership lobby. That's one of the biggest areas for me that I think is, huge benefit of the software world.
You touched on this a little bit earlier. How will AI, as we know it, be a part of what you're working on over the next 5 to 10 years?
Yeah, so AI is of course the, buzzword of the moment. A big area where we're currently leveraging AI or machine learning or insight generation is in data analytics. Of course, autonomous driving and autonomous capabilities for, let's say, environments that are really difficult to maneuver in, a mine, for example, or one of the cool things I saw at CES was lunar excavator. Those objects need to be autonomous because you can't remote control them from the distance that they're in, or it's too difficult to remote control. So some of these really harsh environments, autonomy is going to play a huge role. I think in the manufacturing world, the industrial world, we're going to see AI and autonomy start to play much more of a factor than it already has been as it becomes more difficult to find labor. As that labor cost starts to increase significantly, you can get really substantial ROI by introducing a robot to do the job of X amount of humans. Not that I'm advocating for, job elimination, but when we start to talk about maybe some of the really dangerous jobs that have high injury rate, or some of the, let's say, defect detection that prevents a bad part from getting out that a human might miss, because the going percentage is that humans are only 80% accurate when it comes to defect detection. But
Hmm.
you can get a robot that's 99.99999% accurate in detecting these things. So I think we're going to start to see a lot more of this integration. One of the cool things I saw at CES, and I'll leave the company name out of it, they had on display a humanoid robot that was carrying very heavy boxes. So it was just from a fictitious storage area. They just had a stack of boxes, and it was picking them up and carrying them over to the assembly line. That seems like a really good application because now you're preventing someone from getting injured. And when it comes to the AI standpoint, depending on the height of the boxes, it can adjust. Depending on the width, it can adjust. Depending on the distance to the line, it can adjust. So you don't have to really pre-program in all of these parameters. You can allow the machine or the robot to use its sensors in order to adjust its function.
Can you talk a little bit about what CES is, what you were doing there, and some other cool stuff you saw?
Yeah, absolutely. So CES is the Consumer Electronics Show, which really started off as, consumer goods, phones, laundry machines, appliances, computers. And over the years, it's really grown into something that I don't think a lot of people foresaw, which is it's almost become the premier auto show of our continent. There's entire halls that are dedicated towards mobility and advanced vehicle technology now, which never used to be the case before. So you're starting to see companies like Sony Honda Mobility that are releasing what seems to be, an iPhone on wheels, or, a smartphone on wheels, all the way through these, autonomy lunar excavators and everything in between. So I like to go there for really multiple reasons. Number one, of course, I'm always there with the mindset of, are there any business development opportunities, both from a SCAE standpoint as well as a SCOA standpoint or SC standpoint? Is there anything interesting that other people are doing that either we could leverage technology that they're leveraging, or maybe we can connect the dots in some way between our existing businesses or maybe perhaps some new businesses. That can be, so a biz dev approach, definitely. Additionally, seeing some of our customers are located all around the continent, and some of our partners are located around the globe. And this is an event that brings everyone together. So it's a good opportunity without making individual trips to be able to, have some really fruitful meetings and discovery conversations with them. So a lot of relationship management in that sense. And then I think the top item for me is, what's going on in the world of technology right now, because we are just exponentially growing, what we're capable of doing. And I know one of your favorite topics is flying cars.
You know it. And what's funny is that, we did some work together not that long ago,
Mm.
but it seems like just in the time since we have worked together on anything, we've seen things continue to grow exponentially and become more and more exciting. Now, yes, what's the latest on the flying car? How close are we? What's happening with that?
Yeah, I mean, they're here. They are here. I think it's a matter right now of validation testing. So there are definitely some test flights that are, probably in process as we're speaking right now. Even in the New York area, I know there's some flights that are going out of Newark. Some of the big companies right now that, two of them were actually at CES. One of them was Xpeng Aero. They're out of China. And they have this, it's not classified as a helicopter, but it kind of looked like a helicopter. And it folds up and can fit in the trunk or rear end of one of their transport vehicles that they have. And they had that on display also. Super cool.
Wow.
Drew a huge crowd. There was Sambo Plus Mobility, which is more drone focused or airplane focused. That one was really cool. Two companies that I didn't see them at CS. I don't believe they were there. Joby Aviation and Archer. So Joby is a Toyota-backed company, and what we're seeing now is all of these automotive companies are really diversifying outside of just automotive. So like Toyota investing in Joby, Honda has big investments in Honda Air Mobility and Honda Jet. Those are some big areas for them. Stellantis has huge investments in Archer. Actually, some interesting stuff that I read recently. SC and Japan Airlines formed a joint venture called Soracle, and they pledged to purchase up to $500 million worth of Archer product. And so that's really exciting to see us getting involved as well in this space, more like a local air taxi kind of an approach.
So, not to kind of ask again, but when are we going to see flying car traffic?
Yeah, that's difficult. In metropolitan areas, I think it'll be a while. I think people are a bit nervous about that, but more rural areas or certainly like closed loop or closed facility, if it's not here already, I'd say you'll probably start seeing it in the next year or two. The big thing that I believe is at least the current hurdle is the laws surrounding all of this, right? The liability of what happens. Is it autonomous? Is it the users driving it? Who's responsible for that sort of thing? Very similar discussion to autonomous driving, right? At the end of the day, it comes down to who's liable when something goes wrong. Because as safe as these systems are, inevitably something may happen. And so I think the preparation of that legislature is probably what will be the biggest holdup.
And what will be the difference between an autonomous passengerless car and a large drone? Because some of these things seem to be kind of crossing over into each other. When you mentioned that they're doing some flying car testing over in New Jersey, first thing I thought was about all the drones that they're seeing in New Jersey, and they can't explain what's going on at all. So Maybe that's what's happening there. Well, in the last half of 2025, what might be some things that you'll be excited about working on?
Yeah, we have some really great collaboration between SCAE and SCOA right now, particularly within the auto manufacturing team. There's a lot of support that we're giving to each other in order to advance some of the newer business topics that maybe aren't so well known within Sumitomo Corp right now, but are, developing businesses. So a lot of the execution is coming down to the SCAE team. So we're excited to grow that, expand it beyond the current operation into something much more significant. I'm purposely being cryptic here.
It sounds like there's stuff in the works that you can't really talk about, but you're saying we've got some stuff coming up, so stay tuned.
Absolutely, yeah. And then from the engineering side, really venturing into some of these other industries where we've got some significant pipeline activities planned, perhaps some new partnerships as well throughout the year as we work to develop this. Non-equity partnerships, at least for right now. But we're really excited to explore how we grow as a company, and with that, how we grow SC and SCOA as well.
Well, I'd be remiss if I didn't mention my cousin Johnny Pitalo, who has the Johnny Pitalo's Paint and Auto Body Shop in my hometown of Biloxi. Actually, he has it in Ocean Springs, which is the next town over. But one of his bits of wisdom that he gave me is that you can't unbend a unibody construction. So, to that end, how are we able to move forward from what we know about cars and what we understand about cars and really start to think about what the future of cars is going to be when the technology is just going so fast? I mean, are there certain truths like the unibody construction not being able to unbend that will never be different, or is everything on the table now?
I'd say there's definitely some truth to that. But what we're seeing also now is a much larger focus on design for serviceability. So let's say you do bend a component. Now, instead of having to replace the entire cradle, for example, you can replace a small component within that cradle. One of the things that Tesla is doing, and a lot of companies are trying to follow suit, is in the gigacasting, where the entire, let's say, half of the underbody is one component. From a cost perspective, that's great. That's elimination of thousands of components that have to be assembled together. But with it comes a lot of risk of, if something happens, now you have to replace a $10,000 component for something that could have been a small repair. And so again, I think at the end of the day, it comes down to what engineering is a game of trade-offs. And
Right.
so you can't always be everything to everyone. You have to decide, who are you trying to be? What are you trying to do? And from there, maybe you have a really easy to repair vehicle or craft of some kind, but it's still a bit more expensive versus it might be really easy to produce, but really expensive to repair. It just kind of depends on what your objectives are.
I guess my last question to that end, for a while we heard a whole lot about 3D printing and about how that was going to be a game changer in all kinds of different manufacturing. How has that sort of reared its head in things that you've been working on over the past 3, 4, 5 years?
Believe it or not, there is a car that is 3D printed
There's a car that's 3D printed completely.
completely. Zinger is the name of it.
Okay.
Actually, my one of my previous engineering managers works at one of their subsidiaries, and he works specifically on the chassis and the brake components. It's really fascinating, but the vehicle's like $2 million. So
Okay.
for mass production, maybe there's some components that are 3D printed. Sometimes it doesn't make sense depending on volumes to go hard tool something. From a prototyping perspective, it's becoming really, really big because it allows you to, I can move super fast. I'm just making this up. You can print a body panel in a day, but it would take you 4 months to get it if you went through the traditional process.
Well, it looks like different technologies and different things are converging toward, you know, ultimate progress. So I guess that's good news in general, I would say. Justin, thank you so much for talking to us today about what you're working on about SCAEUS, and we'll see you soon.
Thanks, Stephen. Appreciate it.
Take care.